Hi guys, interesting little project here coming from one of my favorite YouTube channels. This is a suspension A-arm component that Craig over at Throttle Garage. This is Craig, and this is his YouTube channel, Throttle Garage. And Craig, if we click on here, Craig has got this ongoing project where he's working on a Volvo Amazon, which is which he is building up as sort of a retro a retro power style of build. So and he's actually done some quite amazing stuff in here with doing infused carbon fiber panels for the exterior work of the car, and lots of carbon fiber parts for like intake manifolds, that sort of thing. So as you can imagine, this is all right up right up my alley when it comes to interesting YouTube content. And then a few weeks ago, Craig was actually put up this video where he was working on suspension components for the Amazon, including well, we're starting off making this lower control arm for the front suspension. And I've reached out to Craig and asked whether I could look at his workflow and replicate the making of these parts inside of Rhino. So here's a little bit of a tease of what we're going to be doing today, and let's dive straight in. So what I've got from Craig is some of the input componentry that he's using. So these are the bushing holders for the inner end of the control arm, and if we turn all of this on, this is the ball joint holder, and this weldable sleeve for the ball joint. So one of the first things, well, actually, and also what we have, if we look at our notes, we have a whole bunch of location points for where these suspension components need to be, listed in these XYZ coordinates, and I've just pulled these into some notes inside this in my Rhino panels here. One of the things you will, if you want to replicate this workflow, you'll really want to bring up is this box edit. This allows you to select any particular piece of geometry in Rhino and see its size and see its location. And we're going to make extensive use of that in this workflow. Now, one of the first things we need to do is with this ball cup is I want to center a surface that represents the center of this or the mid height of this cup, and this will make sense later in this workflow. So I'm just going to come to the front view. I'll turn that on to shaded, and I'm going to type section. And if we come down here, let's see if we get no, we're not getting a snap here. I'm going to go to my right view, and yeah, I can snap to the midpoint of the seam, and extend section needs to be turned on here, because that will mean that we throw a section through the whole part. So if I come back to my perspective view and turn that off, I now have two curves that represent that section through that cup. I don't actually need the inner one. I want to turn this one into a surface. So we go surface from planar curves, and then I don't actually need that curve anymore. So I'm just going to create a new layer, and we'll call this ball cup mid surface, and we'll put that into our ball joint layers. And I'm just going to turn on all the rest of these, and what I'd like to do for now is actually group all of that. Now if we go to our wireframe view, one of the things that I've created here is I've ungrouped this again, is I've created this point which is the center of the ball joint. So probably beyond this this video is how you would do that in Rhino, but I actually recreated all of these parts that Craig sent through. I've recreated as Rhino files, and when I created this ball, I also created a point that is the center of the ball, and that's going to be again another piece of geometry that's just going to be useful further along this particular process. So with all of that there, I'm just going to group all of that together. I'm going to turn this up and we'll turn off the ball joint. That should be on the ball cup mid-surface. So if we turn everything else off now, yep, we've got that mid-surface of the ball cup. And the only other thing I'd like to do here now is I want to move this bushing holder to the origin. So just open this up here. I'm going to make sure that my box edit is centered in all three dimensions, and then I can just type 0, and the other ones are already 0, and now I've put that in the bushing holder in the at the origin point of Rhino. I'm going to go to my front view, and I actually want the orientation of this to be facing towards the negative of the y-axis, because that's what our front view is here. So I'm just going to go back to perspective. There's our y-axis, and I'm going to rotate that 90 degrees. And I'm going to be working on the negative x side of this to start, and it's going to be very useful for us to have this seam on the horizontal plane. So I'm just going to rotate this 90 degrees, and so this will make some sense later in this workflow. But having something here that we can snap to can be very useful. So that is now all set up. And I'm going to go to these notes here, and we need 3 points in space. And if we look at this data that's come through from Craig, these the lower wishbone front pivot, the lower wishbone rear pivot, I can make this a little bit wider, and the lower wishbone outer ball joint are these 3 points here. And this is quite simple in Rhino. I'm actually just going to grab this panel and pull it out so it's floating. I'm going to grab this point I just created, and in our box edit we can actually just type in those values. So x 152.50, tab key to the y, and that is minus 300.75. And actually just notice that this is a negative number here as well. So we'll make that a negative. And then finally we're 160 above our Z plane. So if we click off that now, I can now select that point and confirm that it's at minus 152.5x, minus 300.75 in the y, and plus 160 in the z. I'm now going to create a second point, and this one is positive 152.50, still negative 300.75, and again 160. So there's our front and rear lower A-arm points, and then finally let's put in that ball joint point, which is 10 in the X minus 590 in the Y and 167 in the Z. Oh, so there we go. Now if we look at our top view, that's actually forward, or actually that's been spaced out or in the along the y-axis. I want to work with the y-axis actually being my the XZ plane being my front view. So I think at this point we're actually just going to rotate all of this geometry 90 degrees around the origin. We're just going to set that to 0, and we're going to set the rotation to 90. I actually wanted minus 90, so let's repeat that command and put minus 90. And now if we look from our front view, we have those two lower A-arm bushing points are together. We've got 2 points there, and then there's our point for the ball joint. So I think we're done with that information, and we go back to our perspective view. I'm just going to hit save so that we've got those, and I'm going to create a new layer, and we'll call those pivot pivot points. Excellent. I'm just going to grab those 3 items and I'm going to put them onto that layer. And for now, I'm just going to lock that layer so that they do not move. So I can't select these now. Now, the next thing to do is now to actually move some of this other geometry in. So I'm going to pull up my rear bushing, and I'm going to go copy and paste. So now there are 2 bushings there. I'm just going to select one of them. But because this is on the origin, if I can type move here, and I can select 0 as the origin, and then I can just select a point to move to. Now, even though these points are locked, I can snap to them. So, and that's having my my on snaps. My on snaps here. I've got point selected as an on snap. So there's the first bushing, and I'll do the same. I will copy and paste and move to and move to that move those to that location as well. And what I can do here, I'm actually going to take both of these and put them onto the default layer so that I can turn this one, my reference geometry, off. So those are my two lower control arm bushings in place. Now we need to do the same with the ball joint and all its associated geometry. So at this stage, I'm just going to take a copy of the ball joint. And because I've actually located the center of the ball joint at the origin here, I can do the same operation. I can just do a move from 0 and select that point. And I'm just going to hide this version so that we don't need to see it in our working on our working model. Now, what we need to do now is this ball joint has a caster angle and also has a kingpin angle, and we have to add both of those in before we do anything else. So I'm just going to bring this data back from Craig here, and we have a look here. Our caster angle is 4.67 degrees. So I'm going to grab all of this. I'm going to click on my gumball at the bottom here and go relocate gumball. Now if we zoom all the way in, you can actually see I didn't quite move that point to where I wanted it. I'm just going to escape for a second. Oh no, we do have, it is actually in the right place. So let me grab all of this and I'm going to go relocate my gumball and to that point. And then I'm going to press enter. So now I have my my gumball located at the center of the ball and also at the location that our that ball joint pivot point. So our caster angle, which is this this rotation in the YZ plane, is 4.67. So I'm going to click on this. It's actually going to be a negative in this view. So minus 4.67 rotates our ball joint backwards. And then I'm going to do the same from the front view. I'll need to grab this again and relocate my gumball again to this point. And if we look from the front, so from our XZ plane, our kingpin angle is 8.49. So I'm going to click on here. This will be a positive 8.94, and that rotates our kingpin angle. So there we have it. So that that ball joint is now in the correct location and the correct orientation for this particular A-arm. We need to actually create the curves that will create the tubes that are going to run between these 3 points. So that end, I am just going to turn off all of this geometry individually, and let's start by drawing the initial curves. So I'm just going to grab my polyline here, and I have got my mid snaps on here, and if we have a look, because we've got an edge on the in the correct location in the front of these bushing mounts, I can actually snap to the middle of that bushing, and then I can also snap a curve to the middle to the point that defines the middle of our ball joint, and I can do the same from the rear bushing. Just work my way along until I find my mid snap and then connect to there. Now, initially, we could do we can now actually pipe these. So I'm going to select pipe, and I'm going to do a diameter of 25 at both ends, and I'm going to do the same with this. This won't be correct, but it'll show us why we need to maybe work a little bit further. So if I turn on my ball joint weld sleeve, you can see if we're aiming directly for the middle of the ball joint, we're actually going to be low on both of these connections. We really want these tubes to to intersect the middle of our weld cup or our weld sleeve here. So that wasn't correct, but it's kind of what it is giving us is the correct angle from this top view to start. So I'm going to delete those tubes off. I'm going to go back to perspective view. I'm going to turn off that weld sleeve, and I'm going to turn on that mid surface, which is actually the weld sleeve mid surface, if we're truth be told. So it's the center. It's a surface that represents the center line of that weld sleeve. So with that, what I'm going to do now is use the project command, and I'm going to select curves to project and press enter, and then I'm going to select the surface to project to and press enter. Oh, and let's something's gone wrong there. Let's try undo this. We'll try this from the top view, because I think we are it's not pushing in the way that the CP plane should. So I'm going to select the curve, these two curves, and then I'm going to select the surface. And I'm not sure why I'm getting all of that extra information there, but we actually have the curves that we're looking for, which is these two here. So I'm just going to select this, select that extra information which we don't need, and it's actually these two curves here. These two curves projected up to this mid surface, and that gives us an intersection, or gives us a point we can snap to on the edge of this mid surface. And delete these off. I'm going to go to my polyline curve. I'm going to snap to my midpoint on the bushing and snap to this end point on the on this sort of mid plane of the weld point. And I'm going to do the same here. Right. So now if I turn on my weld sleeve, these curves are now now pointed directly at the midpoint on these on this weld sleeve. So I can turn off that mid surface, and I'll actually turn off that weld sleeve, and we can delete that. Now, if I just pipe these, the problem we're going to run into here is they're too short. They actually don't intersect all the way into the geometry at both ends. So what I'm going to do, I'm going to hide these bushings. I am actually going to extend dynamic 25 millimeters, at the end of each of those each end of both of those lines. So with that done, I can now grab those and type pipe 25 millimeters, and we now have two tubes that if I unhide my bushings and I turn on my weld sleeve, these actually intersect or go all the way through at both ends. Now we can now use the split tool. We can grab both of these and we can select the geometry to split that we want split. We can hide all of this. Now if I grab everything, I select all of this geometry at this end and all of the geometry at this end, and then unhide, what we have, we'll hide that one back, what we have is these 25mm tubes are now perfectly aligned or perfectly trimmed off to the geometry that they need to be welded to. So from here, this is actually most of the job done. In fact, I'm going to turn on the rest of our geometry here. Hide this out of the way, and you can see that this is pretty much what Craig was looking for, but done in a Rhino workflow. From here, I can select this, and because Rhino is so good at unrolling, I can just hit unroll, and there is one piece, and if I select this other surface, and we can unroll, and that is the second piece. Now we just check the geometry here. So this heavy line here is where where these curves are split, and so both of those are sort of split to the inside. I think you'll find that this actually needs to rotate 180 degrees, because this much more curved end actually lines up with the angle arriving here, and this flatter end lines up with the much less dramatic fitting on the outboard end. So yeah, there we have it, guys. That is pretty much how how I would approach Craig's problem here in Rhino to produce these parts. I may do a follow-up video to this with maybe some more or with maybe a slightly more sophisticated workflow. I would if you have available the ability to bend these tubes, there would be a way of actually creating these as a curve with a radius, or as sort of a polyline with a radius in it, and actually having a tube that exits the bushing at right angles and enters this weld sleeve at right angles. But for Greg's purposes, this is probably as far as he needs to get. What we could do, though, if I just click hide on this for the moment, and I'm going to turn off the pivots. If we go to our top view, we can take these two, and I'm just going to type, if we go text object and 15mm high, we'll go rear arm, front arm, and file print. And if we can get this onto an A4 at 1:1, we can. So this will just print on a standard A4 sheet, and yep, we'll just do vectored output. That's all good to go. yeah, that's, you could just print this out on a standard desktop printer, and you'd be able to cut the parts out, or cut the paper patterns out, ready to wrap around tubes and ready to cut. So just gonna save that, and let's unhide our geometry again. Hide all this off, and we can make, let's just to make things look pretty, let's ungroup, and then I'm going to grab all of these and put that off to a arm. And let's put a material on here. Go import for material library, metal, polished blue anodized aluminium, and change this to a rendered view. So there we go. That, if it's all nicely painted up, that should be what the final A-arm looks like. As always, guys, if you have any questions about this workflow, feel free to leave those in the comments below, or you can contact me on KauroraCAD@gmail.com. Thank you.